Hi all. Hi all. Today we'll discuss about priority interrupt, polling, and daisy chaining. So all of you know about interrupt. What is an interrupt? So interrupt is a some kind of disturbance to the processor. So interrupt is some kind of disturbance to the processor, and who raises an interrupt means the IO interface raises an interrupt when IO device sends. If this is my IO device, because it is very important to understand when an interrupt is generated. If this is my IO device, this IO device interacts with IO interface. This IO interface will interact with the processor. This processor communicates with memory. So this is the structure that everybody should remember. Here I can have n input devices, IO devices connected to IO interface. So when the processor has to execute an instruction, such as, let's take an example of instruction called scanf in a simple C language. Scanf %d ampersand a. So if the processor wants to complete the execution of this instruction, definitely it depends upon the user. The user has to enter this. In C language, scanf means read the value of variable a entered by the user using the keyboard and store in the variable a. So it involves user, whoever executes the program, they has to enter the data, input data. So it is very important that user enters the data, and processor don't know whether the user really enters the data or the process or the user is ready. It doesn't have any idea, so it keeps that instruction, the scanf instruction, aside and starts executing the remaining instructions. But there may be the situation that the next statement could be printf %d a. That means these two statements are called IO instructions. So until the user enters the data, the processor cannot print the value on the monitor. So it is very important to know that whenever the user enters some data, till that point of time, it is very important to maintain, to keep the processor busy. So here what happens, the user has to, let me redraw the picture. It is very important to understand. If this is my input device, IO device, when it interacts with IO interface, and this IO interacts with the processor, this processor interacts with memory. So this is the structure that everybody should know when we discuss about um, interrupt. So under what circumstance interrupt is generated? So here what's happening when let me take an example, a previous example. C language simple scanf scanf percentile d ampersand a. So the next statement after scanf, let's assume it is printing the value of a, something like this, percentile d a. You know, right? The C language doesn't have doesn't this ampersand indicates the address. So what the scanf function expects when the processor sees this instruction scanf, what it expects. So it expects the user enter some data using keyboard. User has to enter the data using keyboard. So processor cannot wait until the user enters the data using keyboard. The user might be busy, user may take considerable amount of time, and processor cannot sit idle during this time. Our processor, what happens, it has to continuously monitor the IO interface whether the device has sent any ready signal or not. So instead of that, what processor will do, processor tries to execute any other instructions related to the same process or same program or some other program. So whenever user enters the data, let's assume the user has entered the data using keyboard. So when the user enters the data using keyboard, that data, this keyboard sends a ready signal to IO interface. And the keyboard, the data entered by the keyboard will goes to some buffer in the IO interface. It's very real. It's really important to understand this. And you know, IO interface maintains some IO logic, and it maintains the process status registers and buffer register to store the data entered by the input device or to store the data that comes from the processor to send to any output device. So in these cases, what happens when IO interface receives the data stores in the buffer register, and if it receives the ready signal from the IO device, it immediately generates and sends a special signal called INTR, that is interrupt request. Now we try to understand the communication between these two. That is, if this is my processor, or you are calling it CPU, and this is my IO interface, and this is memory. The goal is data that comes from the data that comes from the IO interface cannot go directly to memory. No, it has to, the data has to send to processor. Via processor it should go to memory using some system bus. So as I said earlier, when the IO interface is ready with the data, it sends first, it sends INTR, interrupt request. It sends interrupt request to the processor or CPU. And processor might be busy in doing some other thing. So, or what processor is might be doing? Processor might be executing some instruction, and it might be in the middle of some instruction execution, the current instruction execution. So what happens? The processor uh, completes the current instruction execution, and it receives that interrupt request. It understands it is generated by an interrupt by some IO interface. So it is called hardware interrupt. So remember we discussed about the types of interrupt in the previous class, that it is hardware interrupt. So the hardware interrupt has got higher priority over the software interrupts, then timer interrupt, then IO interrupt. So this is IO interrupt, so it has got lowest priority. So once processor completes the instruction execution, current instruction execution, it performs some housekeeping task like copy the content of PC to some buffer. It is very important because the PC is a special type of register which contains the address of next instruction. So when the processor processes that interrupt, it has to resume the instruction execution. So it is very important to maintain to store the address of the PC, the value of PC into some buffer location. Next, what happens? Uh, the processor sends interrupt acknowledgement, INTA, that is interrupt acknowledgement signal. It sends interrupt acknowledgement signal, then it executes interrupt service routine. In short form it is called ISR, which is stored in the memory, in system memory. Remember, memory is of two types, one is system memory and application memory. So in system memory we have for each interrupt there is a unique number and there is a corresponding interrupt service routine which has to be executed. So this knowledge you should have before understanding this priority interrupts, polling and daisy chaining priority interrupt techniques. So what's happening here? This goes smooth as long as only one device generates an interrupt at any point of time. But it is not the case always. There might be some situations where more than one input devices, see these are all IO devices which are connected to IO interface. So what happens when more than one interrupt is being generated? Then the IO interface, either IO interface has to control or the processor has to control. So we keep uh, two techniques to handling this multiple interrupt. This is called multiple interrupts, handling of multiple interrupts. So see in computer science what happens, everything can be the solution. The problem is we have to handle multiple interrupts. When more than one IO device generates an interrupt, sends a status signal, so IO interface has to generate more than one interrupt. So handling this multiple interrupts is a problem, and the solution is can be find out using pure software method, which is called polling, or you have to accompany some extra hardware. With the support of hardware you can handle this multiple interrupts, which is called daisy chain. See, the problem here is when multiple interrupts are generated, we have to give some priority. We have to process all the anyway we have to process all the interrupts, but Which one should be first? That is the most important. Which interrupt has to be processed first? There comes the concept called priority. So the concept of priority and the concept of polling, software technique called polling, or the hardware technique called daisy chaining priority, all these comes when we have multiple interrupts. These are all the techniques to handle multiple interrupts. So before understanding any topic, it is equal important to understand what is its necessity. See, anyway, we can directly go to polling and daisy chaining, saying that polling is a software technique and daisy chaining is a hardware technique. But what are these techniques used for? Why? What is its significance? What is its importance? So those things should be discussed, and it's very important. So handling multiple interrupts can be done. Handling multiple interrupts means when more than one IO device generates an interrupt, and anyway all the interrupts has to be processed by the processor, but the thing is which one is first, which one should give higher priority, and which one should give lower priority, how to implement it. So it is a job of the processor, because the processor is the one who has to handle multiple interrupts, who has to process multiple interrupts. So definitely it has to implement some techniques to handle those multiple interrupts. Let us discuss. So an interrupt event that can occur while processor is handling a previous interrupt. Simply saying multiple interrupts means when processor is handling a one interrupt, when processor is handling, let's assume interrupt request 1, all of a sudden if it receives interrupt request 2, what should be done? Situation is called, this situation is called multiple interrupts. So the solution is disable interrupt. Remember when we discuss about different priority types, there is a processor status register, and in processor register there is a special bit called interrupt enable, IE. IE stands for interrupt enable. So with this what happens, you can set 0 to 1. So processor will ignore further interrupts while handling an interrupt if you disable an interrupt, if you say IE to 0. But this is not a good thing, because see, when it comes to interrupt priorities, processor has something in the mind. First priority, highest priority should be given to hardware interrupt, hardware failure. Next priority should be given to, let me redraw this. So the highest priority P1 should be given to hardware interrupt. P2 priority should be given to software interrupt generated by the program. P3 interrupt should be given to any timer. P4 interrupt should be given to IO interrupt. So let's assume these are the four categories of interrupts. Most of the interrupts are falls under these one of the four categories. So let's assume the situation P1, P2, P3. P1 being the higher giving highest priority, that is hardware interrupt. P2 is a software interrupt. P3 is a timer, and P4 is an IO interrupt. So why we are saying P1 or hardware has got higher priority means if the processor if the processor is handling interrupt request for P4, let's assume for IO operation, when it is processing this P4 priority interrupt, that is IO interrupt, what happens if hardware sends interrupt request for P1? What you expects when processor is handling P4 lowest priority interrupt, that is IO interrupt, when if in the same time when it is processing the lowest priority interrupt during the course of the time, if hardware generates an interrupt which is called P1 priority, highest priority, then definitely it has to attend the P1 priority interrupt rather than P4 priority. That's what we expect. For that reason, we are assigning some priorities to the interrupt. So whenever a highest priority comes, it has to be processed first, even if the processor is in the middle of processing or executing interrupt service routine related to lower priority interrupts. So this concept is called handling multiple interrupts. You should understand this thoroughly. So disable the interrupt. Processor will ignore further interrupts while handling one interrupt, sequential interrupt, which is not a good, right? Because then what is the meaning point in assigning? What is the point in assigning priorities to the interrupt? When processor is handling P4 priority IO operation interrupt, if you disable that, then even if hardware gets failure and due to hardware failure, if it generates an interrupt, processor cannot attend that. Processor cannot see it because of disabling. So this is one way of handling multiple interrupts, and this is suitable when there is no priority for interrupts at all. This is a good solution, that is disable interrupt. But in real world scenario, it is not the case. We are saying we are assigning priorities to the interrupt, so it is definitely important to give preference to the higher priority interrupt. The goal is when there are multiple interrupts or when the processor is handling lower priority interrupt, and meanwhile if hardware or some other thing generates higher priority interrupt, it has to be processed first by keeping aside what processor is doing, that is processing of present lowest interrupt. So the lower priority interrupt interrupted by higher priority interrupt. We have to give one. This is called defining the priorities. So define priority interrupt. Transfer the control with multiple interrupts. If this is my user program, so interrupt handler can be nested. Transfer of control with multiple interrupts. When it is processing one interrupt, it can generate again one more interrupt. This is called transfer of control with multiple interrupts. So handling multiple interrupts, sequential approach. Once an interrupt handler has been started, it runs to the completion. As we said, this is called sequential approach. So simpler, it is very simpler and doesn't handle priority interrupts well. As we know, sequential approach or sequential way of handling multiple interrupts means it doesn't give priority, it doesn't shoot This approach is not applicable for priority interrupts. Example, incoming data might be lost. Another approach is nested approach. A higher priority device can interrupt a lower priority one. That's what we want to discuss. Priority interrupts. This is called nested approach. The disadvantage is that it is more complex. The advantage is interrupts get handled in the order of priority. Yes, we can implement order of priority in nested approach. So the priority interrupts can be handled by using two techniques. One is called pooling and other is daisy chaining. So pooling is a software technique, as I said, whereas daisy chaining involves some extra hardware circuit which is called hardware. One common branch address for all interrupts. So for all interrupts, one common branch address. One common branch, one address of the service, interrupt service routine. And interrupt sources polled in priority sequence. So polling means processor asks IO interface or device controller related to input devices, do you have any interrupt? The processor voluntarily asks, do you have any interrupt? If an interrupt signal is on, the control branches to a service routine for this source. But the problem is the processor has to same thing like processor is busy and it's an overhead to handle many interrupts can be excessive. The operation can be speed up with a hardware priority interrupt. So polling, what it says, processor has to poll each device controller. Processor has to processor has to poll each device controller one. Remember, for each input or output device there is a corresponding device controller. It has to poll, do you have if it has interrupt signal on, process it. Next it asks this one, device controller 2, if it has an interrupt, execute. Then similarly again this loop is repeated. So processor is busy in polling process itself. It is not suggestible, right? Next comes the hardware technique called daisy chain. So what daisy chain says, it requires some hardware. It is a hardware solution. Serial connection of all devices that request interrupts. Device with the highest priority takes first position. Second highest takes second position. Interrupt request line shared by all devices. So here what happens, I'll give an example. If this is higher priority interrupt, this is called P1 interrupt, P2 interrupt, P3 interrupt and P4 interrupt. So what happens when, and they are all connected, let's assume they are all connected. So when, let's assume P2 has to send any interrupt signal, it, what it does, it opens this connection, this line, and it will send an interrupt to processor. So with this what happens, the lower priority interrupts P3 P4 cannot generate because the circuit is open. Here circuit is open, due to which this P3 P4 cannot send an interrupt because the circuit is open here. Circuit is open here. Circuit is not closed, it is open. But it's higher priority interrupts. If meanwhile P1 want to send an interrupt, yes, it can send an interrupt. So by this way, we are implementing, we are supporting the priorities for the interrupt. This is a simple example I'm giving. So this is called daisy chain. So the priority interrupt, software pooling and daisy chaining in IO interface are interrupt and DMA mode. We have discussed the concept behind interrupt initiated IO. To summarize, when IO devices are ready for IO transfer, they generate an interrupt request signal to the computer. The CPU receives the signal, suspends the current instruction it is executing, and then moves forward to the service that transfers the request. But what if multiple devices generate interrupts simultaneously? That is, when when the processor receives multiple interrupts. In this case, we have to have a way to decide which interrupt is to be serviced first. This is called multiple interrupts. When processor is doing processing one interrupt, if another interrupt gets generated, so we have to set priority among all the devices. The concept of defining priority among devices so as to know which one is to be serviced first in the case of simultaneous request is called priority interrupt. This could be done with either software or hardware method. Software method, as we said, polling. In this method, all interrupts are serviced by branching to the same service program. This program then checks with each device if it is the one generating interrupt. The order of checking is determined by the priority that has to be set. So here what's happening? Even in polling, we can set priority. How? If this is my processor and if it has interrupts to be generated, first it will ask device controller 1, device controller 2, device controller 3, device controller 4. So the processor has to poll. First it will poll TC1 because it has got highest priority. Let's assume its priority is P1. So it is polling first. Next P2. Next P3. Next P4. Here also we can implement the priorities, but the disadvantage is that the device having highest priority is checked first before and then devices are checked in descending order of priority. If the device is checked is to be generating an interrupt, another service program is called which works specifically for that particular device. This is called polling software method. So the structure, the program looks like something. That means the programmer has to handle this. How the structure will look like if the device 0 dot flag, then service it. So this is the technique of looking whether the particular device 0 has any interrupt by checking its flag value. If flag value is 1, yes, it has an interrupt. Else it will go and see why you are checking device 0 first, means device 0 has caused highest priority. Similarly, device 1, the flag value of device 1 is checked like that. So the major disadvantage of this method is that it is quite slow. To overcome this, we can use hardware solution, one of which involves connecting the device in a series. This is called daisy chaining method. So the hardware implementation is called hardware method, as we discussed earlier. It is called daisy chain. So what daisy chain says means, if it has any interrupt to be serviced, if it has any interrupt to be serviced, then it has to do it first. If it has any interrupt to be serviced, then it has to process it. So the daisy chaining method, how it works, the daisy chaining method involves connecting all the devices that can request an interrupt in a serial manner. So the daisy chaining method involves connecting all the devices that can request an interrupt in a serial manner. So as I said in the earlier case, as I connected the persons, these persons resemble, these are the devices that can generate an interrupt. See, they are all connected here. So this configuration is governed by priority of the devices. That means if this is the scenario, just I'm giving an example, and they are connected, this device must be a P1 priority device, this must be P2 priority, this must be P3 priority, and this must be P4 priority. So the P1 priority should be connected first, which should be near to the processor, and this is my processor. If this is my processor, or you can call it as CPU. So the device with the highest priority places first. In this case, this is placed first because it has got highest priority. Next is the second highest priority. Next is third highest priority. Next is fourth highest priority. So the devices with the highest priority is placed first, followed by the second highest priority device, and so on. Next we see the figure. How it works is the most important one. There is an interrupt request line which is common. Let's assume this is my interrupt request line. So this is an interrupt request line which is common to all the devices that goes to CPU. So when no interrupts are pending, the line is in high state. But if any of the device raises an interrupt, it places interrupt request line the low state. CPU acknowledges this interrupt request from the line, enables interrupt acknowledge line in the response to the request. This is normal procedure. So this is the diagram of daisy chain technique. Here you can see that this is my processor CPU, which receives an interrupt and which sends interrupt acknowledgement. This is an interrupt request. The moment it receives an interrupt request, it does some housekeeping task and sends an interrupt acknowledgement signal. So here what's happening, device 1, device 2, device 3. Device 1 has got priority, and device 2 has got priority 2, priority 3. Here priority 3 is the highest priority, something like that. So all, remember, if you observe, all can be sent interrupt request using common line. It is very important to understand this point. This device, this device, this device sends a common interrupt line. So definitely this should have highest priority. Next, this should have next priority, lowest priority. Or it can happen vice versa. It can give an highest priority, lowest priority, then lowest priority. Next device goes on. So this is the structure. Now this signal is received at priority P1 of input device. If the device has not requested interrupt, it passes the signal to the next device through its PO, priority output. So if it has any interrupt, it will set this. If you don't have, it sends the signal to P0. However, if the device had requested the interrupt, that is P1 is equals to 1. If P1 is equals to 1 means it has an interrupt. P1 is equals to 0 means it has no interrupt. So it can make P0 is equals to 1, handing over to the next device. So if the device had requested means P1 is equals to 1 and it has to make P0, PO is equals 0. So the device consumes the acknowledged signal and blocks its further use by placing 0 at its priority output. The device then proceeds to place its interrupt vector address into the data bus of the CPU. The device puts its interrupt request signal high state to indicate that interrupt has been taken care of. So vector address is the address of a survey routine which services that particular device. Like it is an address of a ISR, interrupt service routine. If the device gets 0 at its P1 input, it generates 0 at PO output to tell other device the acknowledged signal has been blocked. So this situation is quite interesting. When it sends 0, it can also make PO as 0. Hence, the device having P1 is equals to 1 and P0 0 is the highest priority device that is requesting an interrupt. Therefore, by daisy chain arrangement, what happens? We have ensured that the highest priority interrupt gets serviced first and have established a hierarchy. So there is another picture which represents the same thing. The only thing you have to understand that here what happens, if device 1 has any interrupt, then it makes P1 is equals to 1, P0 is equals to 0. So similarly, if P2 device 2 has anything interrupt, is has any interrupt, the P0 has to be 1. P0 has to be when only P1 is equals to 0. So this device 2 interrupt cannot be serviced before device 1. By this way, we can ensure that uh, this priority is we can implement This way it is ensured that the priority has been implementing successfully. So what happens if the device 3 wants to generate an interrupt? If then P1 has to be 1. This P1 has to be 1. This P1 can only be 1 when this P0 is equals to 1. P0 can be 1 only when this P1 is equals to 0. And this P0 can be 0 only when P0 of this is 1. It is something like this. So the cycle goes on like this. So what we discussed a hardware approach, daisy chain. Remember, we have to handle multiple interrupts, and handling multiple interrupts is a difficult task which is handled by processor itself. Remember, processor has to handle this interrupt. So when the processor has to handle this multiple interrupt concept, it has two techniques. One is software technique, where the programmer has to take care, where by running a program, processor runs a program to check, and it polls each device. The technique is polling. So it polls each device, do you have any interrupt? And also it polls according to the priority. But the thing is that this is like round robin fashion, it is repeated. But the disadvantage is that browser has to spend considerable amount of time in processing this. And the solution is hardware technique called daisy chain.